Okay, verifying trig identities is just, it's the same thing that we've been doing. But the difference is it's going to be set up as an equation, and you have to make one side equal the other side. Typically when you do this, you want to work with like the more complicated side first and try and simplify it until you can make it equal to the easy side. So on page 362 at the bottom, there are some guidelines. I remember we talked about this. There's really no set way to simplify these, but these guidelines kind of help. So you're not trying to solve this, so don't think about doing things to both sides. So guideline 1 says you're just going to work with one side of the equation at a time. So think more so simplifying or trying to like rewrite things or move things around. See if you can factor things. Um, See if you can replace things, especially when you see a sine squared or a cosine squared. If you see the squared, think about those Pythagorean properties. If you're still stuck, turn things into sines and cosines. Everything can always be turned into a sine and cosine. And step 5, it's the same thing I've been telling you. Always try something, because eventually you will work through it. But if you don't try anything, it's not going to work. So try and find some property that'll work and try something. All right. So let's try a few out. Secant squared theta minus 1 over secant squared theta. And that's going to be equal to sine squared theta. So we want to prove that this is the same as that. And we're going to work with this side because it's definitely simpler, the left side. And I am seeing right away secant squared theta, and I'm thinking of those Pythagorean identities. So I want to write out that one so I can see what I'm going to do here. And I know that, let's see, 1 plus tangent squared theta is equal to secant squared theta. So I can actually plug that in there. So I'm going to replace this with this. And I'm going to have clearly the plus 1 and the minus 1 are gone. So I have tangent squared theta over secant squared theta. Well, I want to kind of rewrite those now because my answer's in sine. So I want to rewrite these in sines and cosines and see what happens. So this is technically tangent squared theta times 1 over secant squared theta. And now let's get to writing these, like I said, in sines and cosine. Tangent is sine squared theta over cosine squared theta. Now secant is 1 over cosine, but since it's 1 over secant is just regular cosine. So this is going to be times cosine squared theta equals sine squared theta. And now we can clearly see that's canceling out, and we have proved that they are equal. Now, I'm going to just do a bunch of different examples, and they're all going to use different methods. So I do have another one for you. All right. 1 over 1 minus sine x plus 1 over 1 plus sine of x. And let's prove that this is equal to 2 secant squared x. Okay, just like we did in the last lesson, I'm seeing two denominators. They are different, and I need them to be the same. So I'm going to get a common denominator. And this is 1 minus sine x, this is 1 plus sine x. So over here in this one, I'm going to give it a 1 plus sine x on the top and the bottom. Over here, I'm going to give it a 1 minus sine x on the top and the bottom. And I'm going to multiply this out, and let's see where we are after that. So 1 plus sine x over 1 plus sine x 1 minus sine x plus 1 minus sine x over 1 plus sine x, 1 minus sine x. Okay, so now the denominators are the same. I can put the two fractions together. Not only can I put them together, but I can also multiply out the denominator. And I'm going to kind of do all of that right now. So 1 plus sine x plus 1 minus sine x. And on the bottom, if I fill this out, it's going to be 1, let's see, minus sine x plus sine x and minus sine squared x. All right, on the top, let's start canceling. On the top, plus sine x and minus sine x, gone. On the bottom, minus sine x and plus sine x, gone. So let's see what's left. 1 plus 1 is 2 over 1 minus sine squared x. And I just kind of realized I forgot to kind of bring down this as an equation. So let me do that now. 2 secant squared x, 2 secant squared x. Because remember, this is an equation. We want to keep it as an equation. We're just trying to prove that it is equal. So the rule I want to use, once again, I'm seeing the sine squared. I am thinking of the Pythagorean identity. That's sine squared x plus cosine squared x equals 1. Why don't I move the sine squared x over to the other side? So cosine squared x equals 1 minus sine squared x. And I'm seeing I can now replace this with this. So 2 over cosine squared x equals 2 times secant squared x. Well, guess what? Cosine squared x is 1 over secant squared x. But because it's in the denominator, if I move it back to the top, it'll become secant. So, or I can let me write it out long ways. So this is going to be 2 divided by cosine squared x, or better yet, 2 times 1 over cosine squared x. And 1 over cosine squared x, hold on, let me move my paper. So that's divided by cosine x, which is going to be to multiply by the reciprocal, which is what we're doing. And 1 over cosine squared x is going to be the same as 2 times secant squared x, which of course is equal to 2 times secant squared x. So that's it. We got them to equal one another. So like I said, there's a lot of different methods. There's never one set way to make this work. You just have to try something. And don't be afraid to try something. Don't just look at one and say, I can't do it. Just try something. I'm going to stop the video here, and I'm going to do a few more after this, but I want you to try these ones out, and then try the other ones, and then do the couple of sample questions that I leave for you. Thanks.